So binary search tree, this is what we had before. So what we're gonna do today is we're actually gonna the tree class that we have right now. That's only for integers. So what we're gonna do is we're gonna convert this, or actually write a new one, and that's gonna be working for all of the data types. So it's gonna be generic data type, and it's gonna be working with any data type that they pass in. So not just integers. I'm not going to modify the same one. What we're going to do is we're going to create a new one, and then we'll copy most of this code over there and see what we need to change from here, right? So first thing I'm going to do is right click on source, go to new, and create a new Java class. So in the new Java class, that's going to be, we'll call that generic. So remember, it's going to be generic tree. Does anybody have questions about what generic is? We went over that in week 1, I believe. So should be familiar. This is going to be a T type, and it should work for all the data type. Add a generic tree, and this is an example. This is the other tree right here. So what I'm going to do here in the source area right here, what I'm going to do is I'm going to add like a package. So I'm going to add a package. First thing I'm going to call that is trees, and I'm going to take the generic tree, put it inside the trees, and the first tree that we created, I'm going to put it in there, and I'm going to add another package. I'm going to call that driver, and all the main classes that we have, I'm going to put it inside the driver class. You should organize your code like this now. You have a driver, which is the main method that's driving your whole class, and then you have the trees branch or whatever directory you want to create. You should have like a bunch of packages in there. So if you're not familiar with that, there's model view controller package. So we don't really have the view in here. We're just using the driver as the view for right now. We have the generic tree. Generic tree, how do we add a generic, how do you define a generic class? So this is a generic tree. Remember, it's going to have most of this stuff in there. But how do we define the generic data type? It's going to be a T and a diamond shape. So something like this, right? So now it'll be able to accept any data type. Then you make T into variable. Yeah. So and we should be able to accept any data type in here now. So now what we're gonna do is we're gonna first thing we're gonna come in here from the old binary tree that we have. We're gonna copy all of the node class first, right? So we need the node class first. I'm gonna copy this. And I'm going to come in here. I'm going to paste all of that. And once you paste it in there, you need to change a couple of things. You need the data type right here, right? Integer is not going to be integer anymore. It's going to be T data type. The node is not coming from the binary search tree node. We're using the node itself. So I'm going to delete this. That should fix it. And the data type that's coming in here, that's going to be the generic. And this node right here, obviously, it's not coming from binary search tree. This is the node itself. I'm going to delete all of this. And the data type that's coming in, that's not integer anymore. That's the T generic data type. So the node class that we have, the next thing we need is the size and the root itself. So I'm going to copy this. I'm going to paste it in here. And this node right here, we're not using the binary search tree node. We're using this node right here. So we're just going to take that out. And here we actually don't need to change any of the data type in here, right? The data itself is stored in a node. So we changed this already. So we don't need to go and change this right here. This stays the node itself. And then what I'm going to do is I'm going to add the add method. So let's add the add method first. I'm going to copy this. And I'm going to paste it inside the tree class. I get a bunch of errors. That's okay. And what things do we need to change? Obviously, this node is a given. We need to change that. And it is still complaining. Why is it still complaining? Should be T element, exactly. So right here, the data type itself should be T. And it's complaining because it's calling this function right here. And that's accepting some other things. So I'm going to go and come and change it right there. And the element itself should be tree. So I'm going to add, and the node, I'm going to come in here, delete this, right? Now it's still complaining, right? So if it's complaining on this part, why is this complaining? And how can we fix that? So not all types are comparable, right? So what we're doing right here is we're trying to compare two values, right? So we had integer before, which is element, and we're just comparing two numbers if they're less than or equals to. But now we don't know what data type that's going to be coming in, right? It could be string, it could be double, it could be any objects in there. So let's say if there's a car object, it doesn't know what to do with it. So that's what's going on right now. So what we need to do is we need to add comparable to this. Well, once we add comparable and compare to method, then we'll be able. So before we add the comparable, what I'm going to do is I'm going to add the contains method in there as well. So if we have the contains method, I'm going to copy this, and then we'll be able to add the comparable. Change the contains, the node, and the data itself, T, and then it's complaining again. Then what is this going on? We're going to come back and fix it in a minute. But first, before we get to that, we need to add comparable. How do we add comparable? So compare to method, right? So it says element dot compare to. I don't have that method in there. So if you look at the list of the methods that's available in element, you don't have any of that. Makes sense? Why don't we have that in there? Because element, remember, is a generic data type, right? And the only things available to that is just equals toString, and we can't really use that either because it's not defined. We don't know what's coming in here. It's not it's not defined particular to generic, right? So what we're going to do is we're going to come in here and we're going to add the generic class. So what we're going to do is we're going to do something like this. We're going to come in here and add that to the generic data type itself, not the generic tree class. We're going to add it to the generic. So does anybody see this a little different? So we have added comparable before. What type of class is that? Comparable is an interface, right? So when we add interface, don't we implement them and extend this for inheritance? So this is the only, well, I shouldn't say only, but this is probably the only time you're actually going to see it comparable implemented this way. So we're doing an extend on the generic data type, and we're using it as a parent class. But any other time you want to implement comparable, and you're going to be using the implements keyword, not extends. But this is the only time you're going to be using it for when you're adding the comparable in there. So what happened with comparable? So let's go over a little review, right? So we have equals, and what is that supposed to return? So when we do, remember, comparable has a compare to method, right? And if it's equals, it returns a 0. If it's less than, it returns -1, or just a negative number, right? It could be -100, could be -50. Remember, if it's less than, it could be any negative number, and if it is, yep. So it is greater than, then it's just any positive number, or if you just put +1, that's okay too. But it's going to be any positive. So that's what the compare to method. So that's what we're going to be using in here. So when we have this right here, when we're doing equals, what is that? That's supposed to be 0, right? So what we're going to do is we're going to get the comparison equals to, and we're going to do element dot compare to current. That's what we're comparing it to, right? And this is going to be either this number right here on line 20 is going to be 0, positive, or negative. And we can use that number to determine where do we want to add the element. And right here, this is what we're going to do is comparison equals to 0. Go ahead, and that's right. And then we need a case for less than. What's the case for less than? Should be -1. So how should we comparison equals -1? Remember, it's any negative number, right? So it's comparison is less than 0 would be any negative number. So we can just type in like this. So even if it's -1, it'll come into this case. And the right would be just a greater than, and we actually don't need to type that in. So 3 cases, equals, less than, and this would be the greater than. And we're going to do the same thing in here. So we have, first case we have is the null case. So there could be a case that the current node itself is null. So we don't need, what we're going to do is we're going to skip that case. We remember compare to only has 3 cases, right? Equals to, less than, and greater than. We already have a case for null. We're just going to return false. That's okay. And what we're in here, what we're going to do is similar to what we did above. We have element compared to current.data, and then this is going to be comparison equals to 0, and this is going to be comparison is less than It was less than before, right? I just want to make sure not. Yeah, it is less than, sorry. It's less than 0. So that would be negative. So one thing I'm missing is, do we want to copy anything else? I think that's okay. We don't need a lot of other stuff in there. Add method is the main thing we need. I'm missing the code I wrote to print the node. I think we did that in the class, so I'm using a different computer right now, so I don't have that available here. I want to be able to print this, so I'm going to go find that code and get that in here. If anybody has that code, go ahead and share it in the chat so I can copy and paste it here. Remember, we had a toString method. I didn't write that. So if you need this code, it is available on Canvas. It's under binary search int tree. We go in there and get the toString method. So the only reason I'm adding that method in here is I want to be able to see the tree printed and see if it's working or not. And I'm going to copy that and paste it inside the node class. I'm going to actually send it in a chat as well, so you can copy that and paste it in yours as well. Remember, I did not write this code. I found it online. I just prints the tree sideways. So it's like a string representation of what the tree looks like, but it's sideways. So remember, that goes inside the node class, not the tree class. Ever since the class started, nobody actually has talked. So I don't know if my speaker is working or not. So if you did say something, I don't think I was able to hear it. Okay. All right. So let's test it out. So we have. I'm going to close this binary search in tree. We're not working with that anymore. And then we have the generic tree that extends the comparable. The generic data type extends the comparable. And then I'm going to create a new driver for this. So I'm going to add another class, generic main. I'm going to add the main method in there. And here I'm going to create generic tree class. And let's start with string. Let's call that string tree. Something like this, equals to new generic tree. And now let's start adding stuff to it. So generic.add. And can you guys tell me one of the new words that you have learned in college or anywhere, unique words? We'll go ahead and try to build a tree off of that. So any unique words, throw it in the chat. Any unique words that you want to add to the tree, go ahead and throw it in the chat. We'll go ahead and iterate. Yep. We'll copy this and start with this. Yep. So we'll copy this line and paste it multiple times. Go ahead and keep typing. We need at least a few words to add. We'll use generic keyword, inheritance, polymorphism. Got everything, most of it. All right. So let's build a tree off of this and let's see if our compare to method is working correctly. And I'm going to come in here. I'm going to try to print the tree. So I'm going to do system or just s out system.out.println. And we're going to do string tree.toString. I don't think this is going to work. I think I'm missing something. Let's test it out. Yeah, so the tree itself doesn't actually have a toString method. So what I'm going to do is I'm going to come in to the tree class, generic tree class. I'm going to add a toString method that actually just prints the node. So inside the tree, what I'm going to do is public return type is string. It's going to be toString, and it's going to say return root.toString. We can check for null if you wanted to. We can do if root equals null. That means there's nothing in the tree. Then what we're going to do is we're going to return. Yes, we can put this in else part if you wanted to, but this should work as well. All right, so now I'm going to come in here and I have a toString method in the tree class. So I'm going to take this out and it's going to try to find that toString method and try to print it. I'm going to try to run it and see what happens. All right, delete what I wrote on there first. So it made a tree out of all the words we had in there. So the root is iterate. And then why is this the root? Why not a different word? Remember, it is sideways. So you have to turn your head a little bit. Yes, so it was the first element added. That's what made the root. Exactly, yep. So remember, if you add something that starts with A, then everything will be on the right side of that A, right? Because everything will be bigger than A. So it depends on whatever you make the root. Later in the course, you'll learn about a self-balancing tree, and you're going to be writing code to self-balance the tree. Balanced tree. What is a balanced tree? Did we go with the balanced tree? So if you have a tree and it goes like this, and it has a bunch of nodes like this. So this is actually not a self-balanced tree. So if you look at this drawing, this is not a not self, but this is not a balanced tree. A balanced tree is something that has the same amount of levels. So it has something like this, and even if it's like this could be considered a balanced tree. And if it has something like this is a perfectly balanced tree. But if it has something one right like this one, this is not a balanced tree because it has one extra here. And this is obviously not a balanced tree because it's slanted to the left a little bit. You want to pick this right here, the root, to be somewhere in the middle of what you're trying to add. So if you're trying to add numbers from 1 to 10, you might want to pick 5 as the root. But that's actually for later, not right now. Did everybody get that to work? So what's the middle letter? So we have 26 letters, right? Yeah. So we have, what's the middle letter that we have? I is the middle. Okay. So we have the middle one. We just have the number things after that a little differently. So if you wanted to switch this around, what we can do is I'm going to take this word, put it all the way at the bottom. Remember, this is A, so this is going to be the leftmost thing. So if you run it again, so the order of the tree is a little different. And if I take this and move it around, that changes the order how the tree is created. So now, what happens if we come in here to generic main and we want to add generic tree, and let's do a car class. So if you try to add a car class, and car, we'll say car tree equals to a new generic car like this one. So right now we don't have a car class. It's going to ask me to add it in there. Create a car class. Yeah, let's go and create a car class. I'm going to add that in the drivers package for right now. And it's complaining. Does anybody know why is it complaining? Why should it be complaining? So does anybody figure out why is car not working and string was working for a class? There is no car object for it to access. We have the car object, right? So we have the car object here. So if you look at it, it's saying exactly. So it's not a comparable object. So we have a car object here, but it's not a comparable object. So it's missing a lot of things, right? So let's take about 5 minutes. So add whatever you need to add, make at least like 2 fields in here, and then add whatever methods you need to add, a toString method, and make this error go away. And use your knowledge from before and see if you can get that to work, right? So remember, we used string before. String is comparable, so that worked fine with this. But the object, the car object that we're trying to add, is not comparable object. So we need to add that in there. So take about 5 minutes to add that in there, and we'll go and get started. So let's go and get this to work right here. So remember, car is an object, is just an object that should work with this right here, but it doesn't have a comparable. It hasn't added comparable. But before we add the comparable here, let's go and add a couple things so we can actually get that to work. So 2 things we should add to the car class. Let's do car. Let's do string color and miles per gallon. Right. So I'm going to add two fields. So these are 2 fields we're going to be adding. And then I'm going to right click inside any class. I'm going to try to generate some of the stuff so I don't have to write it. I'm going to add a constructor that takes both of the parameters. I'm going to right click again to generate. And I'm going to do getters and setters. I'm going to do getters and setters for both of them. And let's do a toString method. I'm going to do toString for both. And I'm going to try to print it this way. This prints the car color. Let's actually take out the car name. It's going to do color, MPG. All right. The toString method is in there now. Now what we can do is I'm going to just use this error and make the class comparable. So what that does is it implements comparable car, and now it's complaining. It's added that interface in there. Now it's complaining about what? What do we need to add to get this red line to go away? Remember, we need to add one method in there, right? And which method is this? Compare to, right? So whenever you have a comparable class, you need to add the compare to method. I'm going to come in here and it says implement method. I'm going to do implement method and it'll tell you which method you need to add. It's going to be compared to and say okay. All right. So now, how do we want to compare one car to another? So we only have two fields right now. I try to keep it simple. We're going to use one of those fields to compare the car, right? So any object that you create, it's up to you, whoever wrote that object, however you want to compare those classes to each other. So I'm going to use, for right now, I'm going to use the color to compare them. And what goes inside the compare to method? What are we comparing? So we're comparing color. So how are we going to write the compare to method? It could be 10 lines of code. It could be 1 line of code, depending on how you implemented it. So if you did it with 1 line of code, that would be just color dot compare to, and this says O, that just stands for other car that's coming in, and what we're gonna do is other dot color, and we're gonna compare those two. Remember, the color is a string data type, right? And string already has a compare to method built in, so we're gonna use that to compare a car object. So go back to generic main, and in here, what we're gonna do is we have the string tree. And we created a car tree. Let's add stuff to the car tree. Car.add, and we're gonna do new car, and we need the color and MPG for this. So color, let's start with what color goes in the middle. So that could be the root. Let's do gray. And MPG, I'm just making up those numbers. Makes sense? You have a car object inside the car tree. I'm gonna copy this line. I'm gonna paste it, and we'll change the colors here. I'm not creative. Go and type in a bunch of colors so I can actually use that. While you're typing in colors, I'm gonna change MPGs here, and this is gonna be 75. Let's do 25. This is 35, and this is 65, something like this. So let's do orange first. Let's do blue. We got yellow. Let's do yellow, green. One more. Did I get everything purple? So we have few things in there. I'm gonna add at least 3 more. We have a full more colors. Red. We're missing a red. I'm gonna add a red in there. What else? Turquoise and black. All right. So now it's gonna build a tree off of this, and I'm gonna come in here and change some of the MPGs so they're not all 65. Let's do 10, 90, and this is, I'm gonna run it and see if it creates a tree, and it probably did, but we just didn't print it. So I'm gonna cut this line, paste it right below it, and change the name. We're printing car tree. So we created a tree, and based off of whatever we passed in. So all the colors are greater than G, so it's on the right side of that. So we can, if you don't want to see all of this, we can come into the toString method of car, and we can try to fix that. And it has quotations. So I'm going to try to print the quotation, take out the quotation, and try to keep it simple. No extra spaces. So it just prints just like this. So now if I come in here and I wanted to change all of this, I don't want my compared to, I don't want all this to be organized based off of the color. I wanted this organized based off of miles per gallon. Where do I need to go and change all of that? Right now, remember, it's all based off of colors right here. So the compare to method, exactly. So if I go to the compare to method of car object, where did it go? Right here. This is where everything's happening, right? So this is where all this is being organized. Whatever this returns, we use the generic tree to add it. We're using that compare to method. So if this T is coming in as a car, we're using that compare to method to get the 0, negative, or positive value, and that is coming from the compare to method. So if you don't want the color, What we can do is we can do mpg minus other dot mpg. Like this work, or am I missing something? But when we were doing compare to, we saw that this would work. So let's run it. So it's going to reorganize everything and add everything to the tree based off of the mpg value. So I specifically tried to add the 50 in the middle, and the values I tried to balance it out. I don't know if I got perfectly or not. So the compare to method right here, this is what you want to use to sort this out, right? So let's say you're working at Amazon and you're sorting the tree out. Everybody's account, you're working with account object, and you're sorting everybody out with the name, right? What if they have the same name? What should you do the compare to method on next? Then in that case, you would go to like email, you would go to something other than that, right? And all that is happening inside the compare to method. So your first thing you'll compare is miles per gallon. Oh, I'm sorry. For account, Amazon account, you do name, you do email. After that, you'll do phone number. You'll keep doing that, and that's how you would create the binary search tree. And all the data is based off of binary. So most of the Amazon interviews, if you're working on the data structure, the backend code, they're going to be asking you questions based off of. So MPG is an integer class, an integer data type, right? And I don't think integer has built-in methods that we can use. So if we let's try this. MPG doesn't have any built-in method. So what we could do is if we had an integer data type instead of primitive data type like this one, then we may be able to do it. This may have that method built in. So yeah, this one has it. But the primitive data type doesn't have any built-in methods, so we're not able to use anything. But if you had this, yes, we were able to do it for string, because string is an object class and it has to compare to method built in under. And if you hold control, you should be able to go into string class that's written by Java, and you'll be able to see it is a comparable object right here. So this is the code that's written by Java that we're using for string object. So if you come to any string right here, hold down your control key, and you can go into that code that's written by Java for us, and you can actually see what they're doing in the back. And this, you can see it implements comparable interface, and it has a compare to method. If we try to find the compare to method, we can and this is some kind of fancy code to compare two strings. If you come in here to main generic main, and have you guys used tree set before? So tree set is the data structures, right? And we can actually define that data structure. And this actually works similar to our generic tree class. And let's find it, and we'll go in and we'll be able to see it. And now, if we wanted to go in, I can hold the control and go into that class. And this actually right here. So it's actually using the put. So if you go in and look further, you'll be able to see that their add method looks similar to ours, and what they're doing is they're doing equals and similar to what we're doing right here. Obviously, it's not as extensive code as what they did.